and you're watching basic to advanced Pyro series inside of Houdini. If you like the content, make sure you subscribe and join our Facebook page. You can also head to our website and check out our courses on Houdini, Phoenix FD, Typeflow, etc. and book yourself a 7 days free demo class and watch by yourself how some of the students have made to the top studios in just 2 months of our course. Alright guys, so welcome back to the part 4, and this is the last part for the simulation, and in the next part we are going to cover the rendering portion of the smoke. Okay, alright, so in this part we are going to learn about what is like gas disturbance, and in order to learn about it I've made a quick setup where I've just made this box and I'm just going to do a sim over here. Alright, so okay, so before really going into what is gas disturbance and how is it different, you know, from like gas turbulence, so there are like lot of forces which we can apply onto smoke and everything, but let's right now learn about like what is you know, the difference between the turbulence and the disturbance. Okay, alright, so what happens in turbulence is just like, you know, it creates a it affects the velocity field. Okay, and so let's say if we have a container, like if we have this grid, and when we add some turbulence, it will just start affecting the velocity field. And let's say if a vector starts from one point, it will just keep on moving to like however the strength is like applied to it. So let's say when we apply turbulence, it will travel from one point to the other across our world space, and that is exactly what happens in reality also. But disturbance, so turbulence is something like which exists in reality, but disturbance is something which is like completely made up, and this is more like, you know, a artificial force which is added in the smoke in order to give it like, you know, more small kind of details. Okay, so let's talk about like what this disturbance is and why do we need disturbance, and why we have why we prefer it over, you know, why we prefer it over turbulence. Okay, so first of all, like gas disturbance is a kind of, you know, it's a block based force. So block based force, it's like a kind of special force. So what happens in this, like, so let's say this is like our grid, so this is our pyro grid, or whatever, like it doesn't have to be a grid. Just think of this as a world space, like the Houdini viewport. So what it does is it will start making a block size, and that block size you can just define how big those blocks will be. And now what happens is like it will so let's say if one force, so there's like one vector and second vector, so let's say if one force starts from here, it will just, you know, diminish over here, it will just end over here. And if it, so next force which starts from here, a vector which starts from here, it will go to here, it will diminish, and then so on. So what happens is like all those forces, they are happening inside a fixed size, a fixed box. So like one box is like not really trying to interact with each other, so it's not like it cannot interact. Obviously it will interact, because if it cannot interact, it will look like really weird. So please mind my drawing. All these boxes have to be of the same size. So whenever a turbulence starts, so like whenever a vector starts affecting, it will just move, you know, in this fixed grid pattern. Okay, it won't go out, or, you know, it won't go in. Whereas in turbulence, what happens is like, so this is turbulence and this is disturbance. So turbulence force, it doesn't consist of any block. It starts from one point and it will just keep on traveling as long as, you know, like the grid allows it. But in case of disturbance, it will travel from one point and it will just stop there, and maybe in the next block it's going to travel from somewhere else and it will stop. So everything will just be dependent upon that, you know, that block size. All right, so now let's just go and see what it really does. Okay, so here I'm just having a sim where I've just added some density in this box. Okay, and I've just activated this density for the 5 frame itself, so it's not getting created after those 5 frames. Okay, all right, so if I just add first I'll just add a gas turbulence, and I'll show you the difference between the turbulence and the disturbance, because it's like really important to know like what we are really doing instead of just shooting in the dark, which most people do, sadly. Okay, so let's say if I put the scale to something like 1, so this is like some amplitude, and let's say if I put the source size to maybe 2, so you'll see what's going to happen. It's just going to deform the smoke completely, and this is the nature of turbulence. It will just start adding turbulence and it will just start deforming everything. Okay, alright, so now let's talk about the gas disturbance. So I'll just disconnect this and I will just add a gas disturbance. And when I connect this over here, and let's say if I put this 10 to, let's say it's 25 is fine, and I can just turn off this and make sure the mode is set to block based, not discontinuous, because discontinuous will more or less like work like turbulence only, and I don't really understand like what's the point of this. So just make sure it's set to block based. And here in block based, so this tells about the size. So let's say if I put it to 1, and let's say now if I start adding turbulence, so you will see something happens. There are like small boxes and all the force is acting inside those boxes. So let's say if I increase the box size to maybe let's say something like 5, and you will see something is happening, and maybe I'll put it to 2 because 5 is just too much. I'm trying to just make the turbulence and the disturbance noise size the same, and you will see something is happening over here. And the thing is, how it's making different from turbulence is, you know, it's like not really you know, having like, it's not really distorting the shape that much. Obviously it will distort if you add it too much, but you will see like it's still trying to prevent it from, you know, completely going haywire. Okay, and in case of so what it's really doing is, here everything is like happening in a block based pattern. And one very obvious thing is like, if you try to increase the block size too much, obviously it's going to affect, and it will just start doing like it will start just carrying on the smoke everywhere. But if you compare it from the turbulence, okay, you'll see turbulence just right away it will just, you know, distort the shape. But gas disturbance, it always try to, you know, it tries to keep it, you know, it tries to keep the shape as it is and then add forces on top. Okay, so that is the main thing, these block. And obviously we are never going to use this big block size. We are always going to use maybe 0.2 or 0.1 or something like that, and see how it tries to, you know, keep everything in proportions. And instead, like if I just use a gas turbulence, and maybe if I decrease the size to let's say 0.3 or something, you know, it will just completely randomize everything. Okay, so that is the main difference between the gas turbulence and disturbance. So what disturbance will try to do is like, so let's say if we come over here, so okay, so let me just draw a silhouette of smoke. So let's say when we have this smoke plume rising, okay, so like we have already got some interesting looking shape. So this is our plume. Okay, we have all the gas vortex confinement, and I've already shown you, so just make sure to watch previous parts how we can add details over here also, and how we can have some big details also. So now let's say if we add turbulence on top, so turbulence, what it's going to do is it will like, it will, you know, it will add everywhere. Okay, and it's going to also add on these edges of the smoke, and you know, it will just distort the shape. It will just like completely randomize the look. But in case of when we talk about disturbance, it will only affect, you know, it will only affect a like a certain block size. Okay, so it's only going to affect those certain blocks. It will try to just keep everything in that block. So the smoke which is affected over here, it will never try to move from here to here. So you know, it will never distort the look. But in case of turbulence, what it's going to do is like, you know, because it's like world size noise, so it will just take the smoke from here and it will move till here, and this smoke will go over here, and it will, you know, just get, it will just start looking very bad. All right, so now let me just go back to my original flow. Okay, so we had this thing, and like we were having this. So let me just go to my camera view now. Okay, and we got this sim last time. Okay, so let's see what we were having last time. So I started with the density and temperature, then I added some diversions, then I added some small velocity in order to look that static look, then I added a big velocity field to add some big randomization forces. Okay, then I added the vortex confinement in order to like preserve the small details which get lost during the simulation. Okay, so till here everything is done. Now the last part is to add gas disturbance, and that is used to, you know, break up these smooth looking patterns. You can use turbulence, but it's just that gas disturbance is going to work much better in this case. All right, so I just use this node. Okay, now I'm just going to add a new node over here. Okay, all right, so let me just add this gas disturbance. Okay, and I'll just put it over here, and just make sure this threshold range is like, you just uncheck it, because it will just do some things which I don't want. It will like try to minimize forces like disturbance on the on the dissipated areas, but I don't really want that. And in this mode, make sure to set it to block based. Okay, and the blocks base block size is set to 0.2. That is like a little bit higher for our taste, so maybe I'll put it to something like 0.1. okay, and let us just do the sim and let's see how it's looking. Okay, so I'll just go here and maybe I'll just increase my cache memory, and I'll just decrease the resolution for timing. Okay, let me just do it and let's see how it's looking. Okay, so I'll just make a preview right now and let's see how it looks. Alright guys, so the simulation is done, and you can see we have got rid of those I mean, obviously right now this is a kind of low res sim, but you can see we have got rid of those that like perfectly circular plumes, and now we are having lots of noise to it. But the biggest thing is, at the same time, like, we are not really losing the overall silhouette of our smoke, and that is something like which is really necessary, because we worked a lot to make a good looking silhouette of the smoke, and if we just lose it with the force, there's no point of doing all that stuff. Okay, and now everything is looking really good, but now it is a problem. So every good thing comes with a problem. That's a law of nature, because now you can see, like, we are having these small areas where this disturbance is also like acting up. So the problem is when the smoke, it gets thinner on the edges, it will just keep on adding more and more disturbance to it. And now the problem is, okay, so if it does that, it's going to ruin everything, because it will make everything look like very puffy, like very busy kind of thing, and it will just take away from that large explosion like kind of look. So now what we need to do is we need to do something in order to like map it. So how we are gonna do that? Okay, so I'll just explain you what we are going to do next is, so right now you can see that this is smoke, like it rises up, okay, and there are some leftover smoke which is over here. And right now what's happening is, like, the disturbance, it's getting added over here also. So it's getting added over here, and it's also getting added over here. And the biggest problem is, like, let's say the overall intensity of the disturbance is, like, let's say 25. So the amount of the amplitude is getting added same over here, and it's also getting added same over here. So that is something like which is very that's not really correct, because the speed over here, the smoke over here is like very low, so it shouldn't have that much of disturbance, because this is, once again I told you, this is like an artificial force. This is just to break that even look on the plumes of the smoke, especially on the top parts. Alright, so now what we are going to do is we are going to basically get the speed of this smoke. So I'm going to calculate the speed of this smoke. So let's say if the speed ranges from 0 to, let's say, 50. So like 50 is the highest speed. So what we can do now is, we can map the disturbance in such a way that, okay, so we are going to map the disturbance in such a way that wherever the speed is 0, it's like the amplitude of the disturbance will also be 0. So let me just write speed over here, speed of smoke, okay, and this is like disturbance value. Okay, so wherever the speed of smoke is like 0, the disturbance will also be 0, and wherever the speed is going to be, like, let's say the highest speed is 50, so the disturbance is like whatever it is. So let's say if I put it maximum to 25, it's going to be 25 only where the speed is like maximum. And let's say where the speed is like 25, the disturbance value is going to be 12.5. So we will get in like even distribution over everywhere. It's not like on some places it's going to be very high, and on some places it's going to be very low. And wherever there is like a speed which is around 0 to 1 or something, we can just exclude that part, okay, using a remap control field. So now let's just fix it. Okay, alright, so the first thing that you need to do is, like, tell your Pyro solver to like calculate the speed of your simulation. Okay, so the speed of the simulation is like it's a kind of velocity field, but now it's like rasterized into just one float value. So just click on this calculate field. Okay, but the thing is, you cannot really get the values of that speed field, and it's not going to do anything right away. So what we need to do is we just need to go back to our I'll just copy the path of this .NET, go back to your SOP level, and just add this .io, okay, and paste your network path over here. Okay, we are just bringing in the cache, and I'll just change it to Pyro. Okay, so we will have like right away it's going to give us some fields. It's going to give us density, it's going to give us velocity and all, but I don't really need any of them right now. We are going to need that when we are going to render stuff. So right now I only care about the speed field. So if I write speed over here, as soon as I'll do that, you will see we will definitely get something. Okay, and right now it's set to invisible. If I put it to smoke, you can see we are getting something. So that means the data, it does exist, but once again we cannot really see any attributes on it, because this is more of a a smoke field, a density field. So it's we cannot see the geometry spreadsheet because they are more of point attributes and primitive attributes. So in order to see the value of this speed field, you need to add a volume slice. Okay, so when you add a volume slice in this source group, just choose your speed field. Okay, and this attribute, so here it says density, and you will see, you will just right away you will get a density attribute and you will have all the values. So the thing is, it doesn't really means anything, so you can just name it whatever and it will just redirect you to the speed field only. Okay, so I can just call it speed itself as of now. Okay, so this is speed, and if you come over here you will see it says speed. So if I just click on this value, so the maximum value we are getting is like something around 17 or so. Okay, it doesn't needs to be correct, it doesn't needs to be like perfect. You can just come around the values, it could be 10 or 5 less or more, it doesn't really matter. We just need to remap it using something. Okay, so right now the disturbance, in the disturbance, if you go to this control field and you click on this control field and just make sure you type speed over here, and also just make sure that you have it on your Pyro solver. Okay, so I'll just write speed over here, and in the control range I'll from 0 I'll put it to like something like 20, because it was set to 17. As a safe side I'll just put it to 20. Okay, and you can also turn on the visualization and everything. As of now I'll just let me do a sim and let's see how it's really looking. So one more thing, so when we use this speed field, so the problem, like when we use this control field, the problem is like sometimes we cannot really see the effect of our disturbance. So you can see we cannot really see it. Okay, so we need to go and increase the strength. Okay, all right, so what I'm gonna do is now I'll just go back here into this disturbance, and let me just increase the strength. So maybe I'll put it to 250 or something. Okay, and let's see how it's looking, and you will see we are getting something. Okay, and right now the base block size is set to 0.1. we are going to change that also in a moment. And you can see again we are having the same problem again, that in this area where the smoke is like coming to a halt, we are still having lot of disturbance over here. So in order to fix that, you need to go into this control field and you need to click on this remap control field, and in this remap control field just bring, so this is telling wherever the speed is 0, the value, the strength is like 2, like the strength is like 0, and wherever the speed of the smoke is 20, the strength will get multiplied 20 times of that. Okay, so if I just bring this this value over here, so what it's going to do is it will just anything, any speed, like any of the smoke voxels which will have a speed less than, like let's say maybe if this is 0 to 20, then this might be like value of 2 or something. So if the smoke is having a speed of 2 or below that, we are not going to apply any of the disturbance there. So let me just do it once again and let's see how it looks. So we will just see that here you can clearly see like we are not really having any effect of disturbance over here. And like in order to like visualize this even better, what you can do is you can just go into this visualization and click on this visualize turbulence. Okay, and again here in the guide range you can put it to 0 to 20, and you will see this red area is like where the turbulence is, like where the disturbance is most, and in the areas where where it gets blue and it fades away, at those points like we are not really having any turbulence. Okay, so for me it's like not really useful, so I'll just let it be something like that, and I'll just do a a high res sim to like really see how it's looking. Okay, so I'll just do a sim and let's see how it looks. Alright guys, so some of the frames have been done simulating, and you can see one thing that the simulation is like not looking perfect obviously, but one thing that we can really see is like we are like not really having, let me just okay, yeah, fine. Okay, so you can see we are not really having effect of disturbance on this low moving areas. I mean, even if it's there, it's like very low. Okay, it's very slow, and everything is like working overall. The only thing which I'm feeling, you know, it's like kind of looking very busy over here, and that is like certainly due to the strength. So I think the strength is like too high right now, so I'll just decrease the strength to like I'll just decrease like maybe 40% of it, and then we will see how it's looking. Okay, so let me just go back to the disturbance, and in the strength maybe I'll put it to something like 100 or maybe 130, something like that. Okay, so just let me do one more sim and let's see how it looks. Alright guys, so the sim is done for few frames, and now I think it's like looking really good, and this is exactly what I wanted. So you can see we now like this is just looking perfect, you know. I mean, obviously the resolution is not that good right now. We can surely crank it up, but you can see we are having small details, we are having large details, we are having not those you know, perfectly circular plumes, and I think everything is just working out very nicely. And now I think it is the right time to just render out our smoke. Alright, so let's just meet in the next part and we will render it. Okay, bye bye, take care.